Recently, I came across an interesting problem. I thought I should be sharing this problem with you. It has two diodes connected in parallel to a battery through a resistance of 500 ohm. Current voltage of both the diodes as well as forward resistances are given. And we are supposed to find I, I1, I2 and V0 as depicted in the diagram. So let's begin. So before we proceed with the solution, let us mark various points on the circuit diagram. Point A, point B, point C, point D, point E, and point F. To benefit the beginners, I decided to redraw this diagram. Just watch how really I'm doing it. Now complete the current distribution. Current in this arm is I1, current in this arm is I2. They combine at point E and constitute current I. Now apply Kirchhoff loop rule in the loop A, B, E, F, A. I'm considering the case that algebraic sum of potential drops in a closed loop is 0. Thus, plus I is to 500 as current passes through the 500 ohm resistance, and then plus 0.7 plus 50 I1 as current passes through diode D1, and then minus 5 is equals to 0 as current passes through the battery, or 500I plus 50I1, and that should be equals to 4.3. This is relation number 1. Now apply Kirchhoff law in the loop A, C, D, F, A. Plus I is to 500 as current passes through 500 ohm, and then plus 0.6 volt plus I2 is to 75 as current passes through the diode D2, and then current entering through the negative terminal, and that is why minus 5 is equals to 0, or 500I plus 75I2, and that should be equals to 4.4, relation number 2. As I2 can always be replaced by I minus I1, so the above equation will change to 500I plus 75 I minus I1 is equals to 4.4, or 575I minus 75 I1, and this is equals to 4.4. This is relation number 3. Now we have two equations in two variables I and I1. They can be solved simultaneously. What I suggest, multiply this relation by 75 and this relation by 50, and then add them up. Let's see that what do we get as. This is 75 multiplied by 500I plus 50I1 equals to 4.3, and then 50 multiplied by the relation 575I minus 75I1 equals to 4.4. Now you add them up. Now as you add, you will see this term will cancel, and what do we have? We have 75 multiplied by 500I plus 50 is to 575 bracket I, and this is equals to 75 into 4.3 plus 50 is to 4.4. This adds up to 66250I, and this adds up to 542.5, or I is equals to 542.5 divided by 66250 amperes. This is approximately equals to 8.189 milliampere. Substitute this value in relation number 1, and let's see that what do we get. This is 500 multiplied by 8.189 multiplied by 10 is to the power minus 3 plus 50I1, and this is equals to 4.3, or this is equals to 4.094 plus 50I1, this is equals to 4.3, or 50I1 equals to 4.3 minus 4.094, and this turns out to be 0.206, or I1 is equals to 0.206 divided by 50, and this is equals to 4.12 milliampere. Now the value, now I2 equals to I minus I1, and this is further equals to 8.189 minus 4.12 milliampere, and this turns out to be 4.069 milliampere. Now thus we know the value of I, we know value of I1 and the value of I2. So these values are known. Further, we also wanted to find value of V0. V0 happens to be potential drop across diode first or the diode second. So let's calculate it as the potential drop across diode D1. This potential drop across D1 and D2 got to be same, and this is equals to V0, that should be equals to 0.7 plus I1 multiplied by 50, and this is equals to 0.7 plus the value of I1 is 4.12 is to 10 is to the power minus 3 is to 50. And let's calculate this further. This is 0.7 plus 0.206, and this is further equals to 0.906 volt. So this is the required answer. Thank you.